try to solve another Leetcode problem, 654 maximum binary tree. So we are giving an integer array nums with no duplicates. So this is very important. So this kind of information for us to build the binary tree. So a maximum binary tree can be built recursively from the nums using the following algorithm. Yeah, so for such kind of problem, it tells us how to use the recursive function to write the program. So the first step is that we're going to find the root node. So this value is going to be the maximum value in nums. So for this example, this is our array, and the maximum value is going to be 6, and this 6 is going to be the root node. And the second step is that we're going to recursively build the left subtree or the subarray prefix to the left of the maximum value. Yeah, so this means we're going to recursively build the left subtree. So what's going to be the left subtree? It is on the subarray prefix. So it means from the beginning to the left of the maximum value. So this means from 3 to 1, it's going to build the left subtree. So for example, 3 to 1, it's going to be the left subtree. And 0, 5 going to be the right subtree. As you can see, this is 5, this is 0. And then for the subarray, we're going to recursively call this function. So for example, 3 to 1, we're going to find the maximum value, and we find 2, 1. Because 2, 1 at the right side, so 2, 1 going to be the right subtree of this node 3. And continually, we're going to call this 2, 1. So 2 going to be the root node, and 1 going to be the right subtree. So 1 going to be the right node. Yeah, as we can see, this is just according to the description. So, according to this kind of description, we're going to build the maximum binary tree. So this kind of problem is called create tree problem. We are giving some information, and we're going to create the tree by using the array nums. Yeah, normally this kind of a question is that we're going to use a DFS function to solve the problem. Yeah. So inside the DFS, I'm going to prepare the nums. So for such problem, normally if there's nothing inside of the nums, I'm going to return a num. This is going to be the leaf node. Yeah, because it is a leaf node, so it's going to be I just prepare a none for the leaf node. And now I need to know the index. So by calculating the index, because all the values are unique, there's no duplicates. So this means we can use the nums index with the maximum value of nums. So if we get the index I, it means the maximum value. So we know the maximum value. Yeah, so we're going to build the tree node. It's going to be a tree node. We're going to build one. It's going to be nums I, because nums I is going to be the maximum value. And node dot left is going to be equal to DFS with nums from I. And node dot right going to be equal to DFS nums from I plus 1 to the right side. Yeah, and finally we just need to return the node. And finally we just need to return DFS with nums. As you can see, the code is not so difficult, and the difficult part maybe we need to understand what is the meaning of the problem. If you understand it, definitely it's going to be easier than you expected. Now let me just run it. As you can see, it works. Now let me submit it to SAC if it can pass. As you can see, it passed all testing cases, and the time complexity is O(n) squared, and n is 1000. So the O(n) squared, because we are running the DFS, we're going to traverse the node one by one. But because we are using this kind of a method, nums index and maximum nums, to calculate the index I, so for such time complexity, this is another O(n). So that is why it's going to be O(n) squared to solve the problem. Thank you for watching. See you next time.